Hey, hey everybody. How you doing? We have a full house today. 4 people and someone brand new to our awesome Quarkus team, Steve. Steve's our new community manager. So Steve, you want to say a few things about yourself before we kick it off here?
Yeah, cool. So up until recently, I worked for this small company called IBM. Tiny company, but came over with a few others and just jumped right into carry on doing Java stuff. So luckily, there's a great opportunity to help spread the message about Quarkus. So I'm going to be doing a lot of that.
How do you say Quarkus?
Quarkus, yes.
Okay.
Am I saying it wrong?
No, it's just no problem. Okay.
I don't think there's a right way to say it.
No, that's not. Well, it was the first.
There's definitely a wrong way, though.
So anyway, the since we have the new community manager, Steve, we actually kind of like 2 weeks ago or 3 weeks ago, we made a tweet saying, "Hey, if you have questions, you want answer on Quarkus Insights, do a tweet or a Facebook or a LinkedIn or etc. with the tag Quarkus Insights." And we got, I think, like 10 or something, 8 or 10 questions in. Everyone for Twitter, so apparently that's where we need to ask questions. And we thought that, we'll let Steve ask those, and I know he has some questions on his own. But in generally, for anyone who's listening on here, like you'll keep collecting questions on that Quarkus Insights tag, and then if you get enough, we'll do one more, at some point. So normally we do like a section on a specific technical thing. We will continue to do those, but we wanted to try. We'll do one with Q&As, and those who are listening, you just ask questions in the chat, and we'll add them in while we go on. So So Steve,
excellent.
You want to kick it off?
Yeah. So we collected the questions that came up on Twitter, and some of them I think you're going to deal with easily, and I think some of the others will take us down into interesting avenues. So let's see. So the very first one. So I'm going to try not to mangle people's Twitter handles, but some of them aren't actually pronounceable. So we'll see. So the first one, which is a pretty obvious thing, is from, I think it's called Urjaval. And the question is, and I like the way it's phrased, is what is Quarkus like? What does it do?
Jason, do you want to take that one?
Sure. So really what Quarkus is it's a productivity framework for building applications quickly, both in terms of how fast you actually can create them and also in how they run. And so when I say quickly, I mean they start fast. You can launch them in multiple environments. You can run on the cloud. You can run on bare metal if you want to, but we're designed primarily around Kubernetes. So we say Kubernetes Native Java is really the focus for Quarkus. So as part of that, kind of get a little bit more detail, what I mean is that, so to build applications fast, we take APIs that are popular. So we take, for example, the microprofile APIs, which, with things like JAX-RS and using things like Jackson for open source frameworks. And we combine it with other technologies, like if you're familiar with Spring Boot, you can use Spring Boot APIs. So using the APIs that you love and use today, you can build an application and then quickly edit it live in your browser, in your IDE, and then see the results immediately in the browser. And then once you've built your application, you can then compile it down to a really tiny executable, or you could deploy it using OpenJDK, whichever you prefer, and put it up on the cloud for you. And we have extensions that automate all this stuff for you. So essentially, it's building applications quickly and getting them live quickly. So I'm not sure if you guys want to add something to that I left out, but that's my elevator pitch.
I can think that was a very good one. I haven't heard that form before. But
I think that's probably the best summary I've ever heard.
Yeah, that was a really good from I haven't used Quarkus before. I'm an end user. What do we do?
Yep.
And I think I'll add maybe the backstory or the backflip of this one is that to make all that happen, what Quarkus has done is kind of flip the assumptions of how you build applications in Java. So where things tend to be done at runtime, we move it to build time, and a lot of the work we've done is to make sure that existing frameworks like Hibernate or Camel or I can't even think of it anymore. Kind of gets used to that difference. And so where JSONs were an explanation for the end user, like you are using and building applications, then from a like if you're a provider of a framework out there, like Hibernate or my brain is going any kind of framework that wants to be part of this kind of very fast turnaround and small applications, then Quarkus is also like a framework or runtime. Sorry, it's a framework to build to build applications, and that means there's like extension points where you can hook in your framework so you fit into this stuff. So there's like a what do you call that in English? It's a runtime for it's a build time framework to hook in your libraries out there. Yeah, that was a bad explanation, basically.
Yeah, I like Jason's example better.
Yes. I was just trying to say I was trying to say there's two parts to it, right? One
that was a tough act to follow. So.
Yeah. That's it. Another one is just that if you are writing frameworks out there that users are using, you might want to take a look at Quarkus as a framework to make it easy for you to get to native for your framework. That was my I'll try to get to. Yeah.
Well, Max, to build on that, do you want to pitch the Quarkiverse?
Oh, we can, yeah. So on this, so again, the Quarkus is built of is a lot of extensions that are out there: Hibernate, Cogito, Camel. There's some CXF, there's CSF. Some of those we maintain in the Quarkus core community, and then there's just like I'll not say random, but people doing other stuff, and not all of those we can release at the same time or in the same state. So recently we added this thing called the Quarkiverse, or Quarkiverse Hub, which is a Git repository where if you want to write a framework for your library or someone else's library, you just go and sign up and say, hey, I want to make an extension. And we will give you the repository. You control the releases of it. You maintain it. But we just automated all the cross-testing and the whole release process. So you only have to focus on just writing the fun part, not all the boring ones. So that's what we have in Quarkiverse Hub. And the advantage of being there is that you get visible in Quarkus.io, which is our generator. That is not there yet, but it's going to come in anytime soon. Yeah, we expand, like right now, the Code Quarkus is limited just to the core plugins, but we are expanding that to the Quarkiverse soon.
Okay.
So
let's come back to extensions and stuff. I think that will show up. Let's do something a little bit more sort of right at the beginning, because the next question is one I had the same when I started looking at this, and others have asked the same thing. So there is, I think it's Eva Cabazet says, can I start Quarkus without first knowing Spring? And then I'm new to the Java world. So can they start without knowing Spring?
So the answer is yes, but I think Georgios as the Spring guy might be the best one to answer that one.
Sure, yeah. So to the one word, super simple answer is yes. You don't need to know Spring in order to do Quarkus. A lot of our users don't use Spring at all, have never used Spring, haven't even used, let's say, Java EE for that matter. So if you're coming from a Java EE world or a Spring world, then the way we do stuff in Quarkus will just absolutely automatically just click for you, right? Because like the guy said earlier, all this stuff we do in Quarkus builds on existing knowledge. So we haven't re-implemented everything from scratch. So you already know Hibernate. We already use Hibernate. You have the various Spring annotations or the CDI annotations or whatever. We are automatically use that. So all the knowledge you already have from enterprise Java frameworks, like the most prevalent enterprise Java frameworks of the last 10 or 15 years, all that knowledge automatically carries over to Quarkus. You don't have to have that knowledge. So if you're like a new college graduate or something, and you're in to a new job starting, and everybody's using Quarkus there because it's so awesome, and they better be using it. then you don't have to have this knowledge. You can just start from scratch and build your knowledge little by little. Now, in the case of Spring, what we have for Spring is this compatibility layer, which means that if you don't know any Java EE, or you don't know, let's say, the equivalents of Java EE, of what Spring has in the Java EE world, then you can continue to use your Spring knowledge instead of like using CDI annotation. So what that means is that like you use like at auto wired instead of at inject, and that just continues to work with Quarkus. There is no performance penalty in using the Spring stuff, because that's another question I've been asked plenty of times, is like, if I do use Spring compatibility layer, does that in any way degrade the Quarkus experience? And the answer there is no, because the way it's built is like it uses all the very low level Quarkus fundamentals that all the other stuff we build on uses. So I think that's about it from my perspective.
So if you're a Java developer or you're brand new to Java and you want to get started with Quarkus, is there anything in these other frameworks that you're supposed to know, whether it's EE or Microprofile or Spring, that you should know before you get started, or can you jump straight into Quarkus?
You can definitely you could definitely jump into Quarkus, like, and start being productive, well, more productive than you would be with any of these other frameworks, right? Now, obviously, if you're brand new to Java, it's going to be there's going to be a learning curve, like whatever you get into, right? But with Quarkus, I believe that learning curve is like going to be the smallest.
So it's buy a Quarkus book, not a Quarkus and a Spring book.
Yeah, a Quarkus book would be the way to go. If you don't know anything, then just buy a Quarkus book.
Yeah,
we do assume.
Go ahead, Steve.
Sorry, Max. I was going to say we do assume that you know Java in the way that like our documentation explains things, and probably a little bit of familiarity of some, enterprise development, like understanding like web requests, like what they are and that kind of thing. That's not to say that you can't, if you don't know those things, you can't dive in and learn it all. But it'd be a good idea to kind of like read a few tutorials on some of those items first, and then dive into the Quarkus experience. Yeah, no,
I just last week I went through and looked at our guides, like getting started things, and if you go to Quarkus.io/guides, we kind of walk you through the first like basic example, and I would say for that to get started, the only thing you need to have an understanding of is just, hey, I need like Maven or Gradle, but we kind of walk you through every step. So if you just kind of know the basics, you should be able to go. And that said, we are working on making it simpler, but that's not something that helps anyone right now.
So I'm not a Spring guy, and so when I started using Quarkus, I didn't find it hard at all. It was the doc was good, the tooling was good. I just jumped in and started doing stuff, and it was like, yep, this works. So that seemed, I was quite happy with it. I didn't have to learn Spring to get going, and that's good because I wasn't something I wanted to do anyway. Okay, right. So we have more.
Yeah, I'll just say, there was Mohammed here who just posted a comment on our chat saying they never use Spring. We just use Java EE WebSphere. Almost a year over the production with Quarkus, almost 28 microservices so far, and still continue. So that's good to hear. Thank you, Mohammed.
Yeah, that's excellent.
And that's a good segue into the next question. I'm not sure how to. It's. I'm not even sure I can pronounce this Twitter. Let me just ask the question. Well, there's a statement first. The statement says this is obviously copied from our stuff. It says, Quarkus is a Kubernetes native Java stack tailored for OpenJDK HotSpot and GraalVM, crafted from the best of breed Java libraries and standards. It's obviously something that Jason just said. But then the crux is, and I think we just answered this, but I'll ask it anyway. It says, and the question is, Quarkus is limited to microservices. So
that's
one we get a lot, actually.
So I'll start with saying what Jason said. Like, Quarkus is designed, like our design and what drives what we add to Quarkus is by default from the assumption we're going to run as microservices in a container environment, most likely Kubernetes based. Right? And that you'll see that everywhere. But that said, you can also write like command line tools, which you also use in enterprise applications because you want to do some batch programming, that kind of thing. So if you want to write a command line tool, you can do it. In Quarkus, we call that command mode. And so those two are definitely like fully supported and things that are there. But there's nothing in Quarkus that prevents you from doing other things. It's just that right now the focus we have in Quarkus is more on the things you would need, what is important for a container native application, meaning also or like a modern one. And that drives our priority. But yes, so if you want to explore and try and use Quarkus for other things, you can, and we definitely recommend you, and we will love to hear what you do. But the main focus on Quarkus, as it is now, is on microservices. You can also write like monolith if you want to. We don't necessarily recommend it because some of the benefits we do becomes less. Like the more code you put in, things get slower. But I would say that Quarkus focuses microservices and tools around it, but you can write more. People ask us for the majestic monolith. Yes, you can, but we recommend you not to go too big, basically.
Well, if I may add to that.
Sure.
So basically, the way I see it is the Quarkus architecture is the absolute best you could get in the Java enterprise world right now. Like there is nothing better, right? The fact that that's not everything, but so much stuff is done at build time, and there's so much let's say dependency pruning and all that stuff is the best foundation you can have for an enterprise Java application today. Now, to tie into what Max said, is that the problems that we as an engineering group are focused on are primarily the problems that developers face when developing microservices. So like we're not going to solve the like session replication problem that you would have with your like majestic monolith, right? We are going to solve like the fault tolerance problem, because if you're in a microservices architecture, you have to make sure that like one failure doesn't cascade to your whole microservice architecture. So it's more of a like the priorities we have than that there's anything inherently problematic in the Quarkus architecture that would prevent you from doing monoliths. That there is nothing preventing you from doing that. Like it's the best architecture out there. It's just that what we tend to focus on, that we're saying that it's like tailored for Kubernetes or whatever.
So just one thing I think it's kind of useful to share is it's just that if you think about the users of like why would you want microservices versus not microservices, and why is Quarkus favoring microservices? Probably might be like a question some who are listening may think of. And the thing is that when you're building an application that is based on containers and it's utilizing kube, for example, the responsibilities that an application server used to provide classically have moved to the orchestration environment for your containers. So things like redundancy are served by having more than one instance or more than one pod. So the reason why the microservices paradigm is really important is so that you can take advantage of all those capabilities that your provider has. Now, that's not to say you couldn't put a monolith in a Kubernetes cloud environment. You can certainly do so. It's just that if you really want to embrace the architecture, the microservices way is the way to go, and that's why we prefer that. Our APIs are kind of based around that assumption. So as an example, we don't do things like embed messaging brokers or embed gigantic caching layers or things like that, because those are provided by other services. So in the ideal microservices application, you just write the one purpose that your service is trying to do, and then you call out to other things. And so that's everything about Quarkus is built around that, and that makes the experience also easier to use. So that's why we went that way. Now, of course, you may have other philosophies, and that's good too, but that'll always be our preference.
And I saw there was this question from Gonadi. I think I know what he means, but asking to rephrase to give an example. Don't worry about bringing integration. The Spring makes Quarkus like this, like Spring Boot does. I prefer it more simple. So I think he's talking about actually. Well, I'm going to take the liberty and think when he talks about similar things you actually are talking about, Jason, that Spring and other frameworks like it, or like Wi-Fi Java E, is doing a lot of things on top of its core. And I think you just answered it, that we're trying to minimize that by saying, well, things like management and session replications and the others you mentioned, just we don't consider them part of the core stuff that Quarkus does. Someone could decide to make it so and add it if they want to, but it'll be in a separate thing. But yeah, we definitely are very careful about not making Quarkus too complex. But it's always a dance between being simple and being just simple enough, right? That you can also make it too simple and you can't do anything. So yeah.
Okay.
Let's take the next one.
Yeah, let's take the next one. So this is a different change of pace there. So Thomas has asked, and I'll read this slowly, how native Quarkus compilation performs in large monolithic applications, like 50,000 classes. Did you try benchmarking Graal build process? So I think there are two questions in there. Is basically, how does Quarkus perform when you're doing large monolithic applications? And then what sort of benchmarking did you do?
So so the native, when we do the native, so he's referring to when we call out, for example, to GraalVM or Mandrill and call native image. And that one, because of the assumption we take of, the GraalVM has to do is about closed worlds. We need to basically have all the dependencies and stuff available to us. That just inherently will take time. I don't know what this, like how long a 50,000 K classes would do. It's not going to be fast. Depends. So but generally it's a problem that right now, the way that this is architected for native compilation, you either reduce your number of classes or you put more hardware into the game.
Yeah.
The one thing we did doing around benchmarking, and Jason, you might remember more from the past where I was not so much involved, but one thing we did find in the last year was we had a case where we had the client library, which is the community client library. That was 10, 15,000. It was quite big.
The model, the model's huge. Basically.
Yeah, so we had this library that when you put it in native, suddenly our compilation went from being like a few minutes, like 5 minutes, till 15. Like it took longer than we had time for. And there it was actually turned out that was because we gave the machine more, we gave it all the memory that it could give. And it turns out that if we actually squeeze it down, then Graal actually performed better. And so there are tricks like that make sure that you don't actually give unbounded memory to Graal, but keep it down to where you figure out what works best for your case. And then I do know that the GraalVM team is looking for feedback, and we are giving them feedback when we see stuff like this. Like, hey, we have this case where this is working, and we have people also looking at it from time to time. But I don't know, do we have anything from the past, Jason, of performance?
Sure.
That's the general.
So there's a few things I could say. One is that Quarkus itself was actually designed to handle very large class paths. We have actually tested tens of thousands of classes, and it does actually run decently. GraalVM, it depends on the way the application is architected and how those classes are utilized. Because I think Max, you're talking about dependencies, and if you have a if you end up with you have a monolithic application that is really truly using the full surface area of all the APIs that are out there, that is definitely going to not give you as much of an advantage, because the way that the dead code elimination process works is it's all about snipping out stuff that you don't use, which when you're building a microservice, right, that's the case. I mean, if you think about it, like if you use JPA, right, like for example, you're writing persistence to a database, do you use every method in your application? Usually you don't, right? So what dead code elimination is all about is it finds what's the stuff that the app's not doing, let's just cut it out. And that's how it works. So if you have a really, really big application with tens of thousands of classes, and you start to cover that full surface area, then the benefits you're going to get for it aren't going to be necessarily as much. Now, it'll still be better in some cases. Now, as to the actual time it takes, the time that it takes to process is certainly going to be in the minutes factor for something like that, because it has a lot of processing to do. But if you think about it, right, like what are you doing when you rebuild your application, right? Well, you're doing a new update. You're going to release a new update to your system, right? So like these aren't things that you do like every second, right? So and then also when you're developing your application, you also don't need to build a native image to test your application. You just do it right in your IDE. So we use OpenJDK for hot development, and that's where it makes sense. And then we use native for whenever you're finally down to that like last image, you're ready to go to production. And then so what we would recommend you do, just to answer the question, is try it out, see how it goes, and see if the savings is worth it for you. And if it's not worth it, then run on OpenJDK, and we do a lot of optimizations there. So you'll get good performance on OpenJDK as well. It's really just about like the needs of your app and what you're creating, and then we try to pick the best path for you.
Yeah, I think that's an important point that well, I repeat it every time we talk about it, but Quarkus is not just native. Right? Native image is like when you want to go to like small distribution, super fast startup time. Whereas VM mode, yeah, you pay a little penalty, but we've still done a lot of stuff at build time, so it's still fast. It's still faster than anything else out there that we are aware of. Yeah, it's not a bad thing running in VM mode. So that's
so you obviously build time is with native is fairly slow. I mean, I've tried just with Graal, I can see, and because it's doing a lot more than what a normal compiler would do. But putting that aside, is there any particular disadvantage in turning? If I have a very large monolith written in Java, the 50,000 class stuff, do I get any benefit from turning it into native? I mean, if I can, putting aside the actual build times, what's the runtime benefits of doing that?
Depends what your app is doing, but you should get faster startup. Like almost by default, just because. If you use Quarkus, like if you just take a normal Java app and just compile it as native, and it still does all the stuff at runtime, I'm not sure you'll get that much of a big thing. But there are some. But yeah, that's at least my experience. But Jason, if you know more.
Yeah, so if you were doing a really big application, what I would expect is in a traditional application runtime that you run in, you're probably going to get like close to you may even get close to a minute in startup time. It depends on which framework you're using and if it's an application server, which application server, and so on. If you start in Quarkus, we're going to do a really good job of making that fast for you. So it's probably going to be a couple seconds, maybe, it could be like 4 or 5 seconds. It depends on what if you do, like, for example, a lot of processing work in your app on startup, then of course it's never going to be faster than the work that you have to do in startup. But generally, if it's just starting right away, it takes the JVM a long time to load lots of classes. So one of the things that we do in Quarkus is when we do our build time transformation, we're actually taking out stuff that doesn't need to happen every time on runtime. So if you think about it, like if every time I start my application in a container, that container is immutable. So it's never going to change, right? So, but every time you start, like, what does a traditional runtime do? Well, it's got to look at all the classes, find all the annotations, figure out what you told it to do, read XML files, read JSON files, whatever, and then it's going to produce something, right? So with Quarkus, all that stuff is done at build time. So when you start, it's literally just the steps that need to start. So big applications can start really fast on JVM mode with Quarkus. They can also start fast with native image. So what will native image give you? The biggest thing native image will give you is it'll give you a snapshotted heap. So you don't have to, if you build lots of stuff in memory and so on, that can actually be quite a bit faster. So you can see an improvement there. Now, the trade-off, of course, is that if you want, if you have a big monolith and you want to work with lots of memory at runtime, like you want to process lots of data, then OpenJDK is going to be the better solution for you because its runtime environment is optimized for managing large heaps. So it has like a better garbage collector for large heaps than what you get if you do native compilation, which is designed for smaller it's designed for smaller heaps. So if you're doing a microservice where it's acting as like stateless REST service, then native compilation is fantastic. If you're building a monolith and you're working with like a gig of state or something like that, then you're going to find yourself more leaning towards that OpenJDK option for you.
Excellent. Good advice. Okay. So we move on to the next one. Well, in fact, this next one has a little edge to it. So Nicholas asks, he says, as a big Quarkus fan, I'm impressed by the low memory usage. He has 2 questions. Okay, so question 1, how much memory do Quarkus apps consume under load, not only startup, both JVM and native mode? So I presume he's trying to compare them with something, but he's basically saying, how much memory does a Quarkus app consume under load?
Well, that absolutely depends on like
workload, yeah.
Yeah, and the workload and what extensions you're going to use, right? So does workload mean like HTTP calls here, or does it mean like reading Kafka events or something? So it really depends, right?
Okay, so reading into the question, what do you have in your devices as to the types of thing that are more that are better memory consumption? What sort of workloads or patterns do you think work well in terms of reducing memory usage?
Yeah, I'll just say one thing is, people have to remember that the native image will use, well, again, in general, not saying always, in general, will use less memory in startup at startup, but once you get going, I don't think the memory sizes are going to be that much different between like a VM mode or a native image, right?
Yeah. So the key difference.
Yeah.
Sorry, Max, if you did, aren't you? Go on.
I'm just saying that over time, the memory will be sizes is probably be comparable, because over time, it's your actual business end use case app that's going to take up space, and it's not like be compressing that kind of thing. But your startup, the pattern you have on your memory user at startup, it will be different. Maybe that's what you're going to touch on, Jason.
Yeah, so I was going to say, one of the things that you can do, that native compilation can do, that's really cool, is it can find fields that you're not using in your objects, and it can eliminate them, and that can reduce the footprint of the size of an object. But again, like that footprint difference, when you think about it, like with OpenJDK's got a better garbage collector for large heaps. So if you have like a lot of state, then some of those memory savings won't necessarily trade off, because like the OpenJDK will eliminate the object quicker than the native image would if you have a large amount of data, right? So if you're, but if you're processing data as requests come in like a REST application, which tend to be fairly low state, you only use state for whenever you have actual traffic coming in, then and those applications run small, then native image is going to be fantastic for you. So like the key though on all this, to answer the kind of fundamental root of the question, is scalability is really what it's about, right? So think less about like what's the maximum amount of traffic my JVM can handle, and think more like what's the scalability of my application running in the cloud, right? So with Kube, you just spin up more pods, and the goal for Quarkus is to consume as minimal memory as possible at runtime, not just at build time. So what we try to do is, we don't use more than your app actually needs. And then as to what your app needs, just try it out and see what you think. So I can say that while Quarkus is a new framework, we use technologies that are actually been developed for years under the hood to do things optimally. So for example, when you're talking to a database, you have a very efficient, optimized connection pool that was dealt with, tons of benchmarks in real world scenarios. So not just like, splashy show benches that you see on the internet. This is like actual what customers were using Quarkus for. What developers were using it, how they were actually seeing these workloads, and then back before that, what were they doing with Wildfly? So we actually took a lot of knowledge that was already out there. So this isn't like something that's untested or just too new that hasn't been built with real world. All this stuff is designed to be optimal for the traffic patterns that you use. So if you want to figure out how much memory you have, honestly, just spin up a test scenario and throw it some traffic and then take a look at what the memory usage is like. And you could use common profiler tools to get a snapshot for what the heap usage is. The one thing to be careful about is you want to make sure that you're actually looking at the state that's in use and not just the stuff that's left over from garbage collection. But there's a lot of information out there that'll guide you on that. And so in summary, I'll say that Quarkus scales to really any load that you need. It's really just about what your use cases are and then having your application architected correctly in the cloud.
And Dimitri's just reminding me of the general rule we've kind of been saying in the last year is like, and not like, again, this comparing like general rule, it's just, you should, as Jason says, go and test your application, because depending on what you do and that behaves, it'll be specific. But for our like general rule, we say like a Quarkus JVM mode app will take about half the space than a traditional Wildfire or a Spring app, and native is like 1/5. But again, this is the startup, and once you get going, it changes very much depending on your dynamics of your app.
And another thing that I want to point out is that we continuously try to improve like runtime memory usage, right? Because anybody that like actually does performance work in Java knows that you continuously need to rerun your benchmarks or rerun your profiling tools to make sure that you're not missing something obvious. Because in Java, it's just like so easy to just like use more memory than you actually have to. So every few months we go through another round of benchmarks, see like what do we miss, how can we make things better, and we often enough come up with areas that we never thought that this would like use more memory than it should, and we take care of it. So it's an ongoing process.
And by the way, just I'll reveal a secret. If anyone wants to like nerd snipe the Quarkus team, it's just to publish that they've seen Quarkus run slow. The whole team just go like, "What? That can't be true." And then we don't get anything work for a few weeks, and come back. Oh, that's because this case. Oh, okay.
Yeah.
No, we very we are very observant on things changing.
Yeah.
Oh, sorry, not change, improving and not get worse, so to speak.
Yeah.
Okay.
So we can sum this up. Jason did mention it in his discussion. But at the end of it, we're saying work backwards, really, because you're looking at the workload you're trying to create and deploy, and that should drive your design decisions. And from there, you decide what works best for you. You know, try and do it the other way around. That's sort of what's the word? Premature optimization. Yeah.
Yeah. Don't do too.
Okay. Well, look, so there was a second part to this question, which I think is just Nicholas having a dig at us. But here we go. So his second part to the question, bearing in mind this is about memory consumption, is he said, would you suggest to use OpenJ9 for running Quarkus in JVM mode? And I will leave you to discuss that.
Well, I could say this, that one of the use cases that we had very early on with Vodafone Greece, who we've had on this show as well, talk about their experience. They used OpenJ9 like wherever they could, right? And they were really happy about how Quarkus performed on OpenJ9.
Yeah, and I'll say like from a Quarkus like community perspective, any JDK should work, any modern JDK, and OpenJ9 is one of those. If you're asking for like how it is for the productized and supported one, well, OpenJ9 is not one of those that's supported, at least not for like a traditional OpenShift deployment. But no, OpenJ9 works, and you get, again, depending on your app, you'll get different behaviors. And you can also get, I know we have a lot of articles about how you'll get OpenJDK to have a similar setup than OpenJ9 has. But it's just a question about defaults that, the OpenJDK and OpenJ9 and OpenJDK guys gonna hate me for it, but because there are more to it. But a lot of the stuff that OpenJ9 does, you can also tell OpenJDK to do. But yes, OpenJ9 is built for a different mindset or setup. So depending on your app, you'll get some benefits for it. So it depends on your use case. Is basically the answer.
That's always the right answer. Yeah.
we actually do test builds with OpenJ9. We have like if you use, for example, if you use Red Hat, so there's you can have different flavors of Quarkus. We have the main community Quarkus. There's also a Red Hat build of Quarkus that's available, and we test that against J9 as well. If you're running on some processor architectures, J9 supports them that OpenJDK does not, like Power and Z, for example. So it's worth if you're thinking about it, it's one of the options you can consider. Part of the reason why we have so much on OpenJDK is just because it's the most predominant JVM that's out there in use, most experience out there in tuning it. So we tend to kind of assume that, but just because we assume that doesn't mean you can't run, as Max was saying, you can't run it on something different. Yeah.
Though what I would really like to see is Quarkus running on ARM32, because then I can have it on my little tiny Raspberry Pi. But that's a different question. Let's move on. Okay, so the next one.
Actually, before you do the next one, I just saw there's another one I think could make sense just before, because we just talked about benchmark.
Right.
BTI says, when it comes to benchmark, do you guys care much about tech and power benchmark? Vert.X used to do rather well there until recently. So I don't know about the last part, but I do know we talk a lot about tech and power benchmark, so we do care. But like Jason or Georges, do you have?
Yeah. So, well, we care in the sense that, like, everybody else is there, so we need to be there. We need to do well. Is right, and we do excellent. Like Quarkus, with our newest REST layer, REST Easy Reactive, is almost as fast as like pure Vert.X, right? So we've got it to like 90 something% of pure Vert.X. So that is like blazing fast for like plain text and JSON and the DB scenarios. We're almost as fast as Vert.X. So that's great. But the other thing that everybody needs to be aware of with the tech and power stuff is that it's a really contrived benchmark, right? So it tests very specific things. Some frameworks cheat. Like if you look at what some of the JavaScript frameworks do to get these amazing performances, like that, they're like basically some of the stuff is like handwriting C code, super optimized C code inside the JavaScript app to get like amazing performance. And so it's easy to cheat when you're trying to like do great on one specific benchmark. So what we always tell people is like what we just said earlier, that it depends on your use case. You need to test for your use case to see like what does, like, I don't know, Spring or Django for a Python framework versus like Quarkus. How do they perform? You really need to see for your own use case. But in any case, in all the standard benchmarks, we do awesome.
And I know we had some numbers pushed like just before the Christmas break or after. Is that public yet?
I'm not sure. To be honest, I'm not sure what if it got published in the latest round or if missed the cut or something. I don't know.
I mean, just to be tight, so we don't actually know if those are published yet, but we do know we've submitted ones where with the new stack, which is better than what we had before. Not that what we had before was bad, but be better now. So
yeah, I can't say in one of the numbers we had a bug that messed up our results. I think one of the questions is Vert.X used to do well until recently. So obviously, because Vert.X is consistently doing amazing on the benchmark, and then suddenly it drops off. It's not like it was just rewritten and then it's terrible. It probably means there's something went wrong, and that's basically what it was. So I think that's probably what you saw.
Yeah.
But generally speaking, I mean, we care about performance. The tech and power benchmarks tend to test, as George was saying, it tends to test like the more bare function, like what's the fastest number of HTTP requests you can respond to with just hello world on like a 5-byte message or something like that, which is not indicative of like what a lot of applications are structured as. So I definitely look at those numbers in reference to that. It doesn't mean it's a bad benchmark. It's a good test of how much overhead a framework adds. Is basically, that's the way I would look at it. This is the overhead the framework adds to provide your needs.
Cool.
All right, let's go.
Okay, so where are we? The next one. This will be fun. Another question from Thomas, and he says Project Loom and Quarkus reactive stack, and in brackets mutiny hibernate reactive, and then the question is friends or foes. So where does Loom fit in all this?
So I saw also there was a chat comment saying last week you're doubtful about Loom, etc. And I think I'll try and capture what I hear is that Loom Quarkus is trying to be fast and performant today, right? So all the stuff we're doing is what can we actually push to JVM and its ecosystem? What's the limits we can get to? And there we just realized we have some of the workloads we see today, reactive is just better, right? And it'll probably will stay that for a long, long time. Any event processing or any kind of let's say lower level, wrong word, but lower level things, you can just end up having a much more better performance with reactive. Loom, on the other hand, is trying to get to a place where we don't have to go in to understand stuff like unis and multis and other things, which I appreciate. I'm definitely not a reactive fluent guy, but I recognize also that with the reactive I can do performance. So I'll say, as I did last time, is we are definitely looking at Loom. We are keeping an eye on it. We actually had a little prototype of using some of the stuff Loom can do, but we can't. But it is something we keep an eye on, and we're not foes. We're just skeptical on when to move. We can't move now because it's not going to be in Loom. Is JDK 16 or 17? I forgot what it's going.
Well, the hope from the community is it will be 17, but realistically, it doesn't look possible.
Yeah. So that's why you get our hesitation. It's just that we want to have something now, not 2, 3, 4 years from now. So we are friends, but they are different approaches, and every now and then we have a concept how do we adapt to this? And as far as we can see, we can adapt. There are some things that are going to be different, but it's just hard. It's just hard to predict on what happens in the future. But so we definitely like what Loom is doing, but So I'm trying not to be the skeptical part. Is not because we don't like the idea Loom has, but we just know there are limitations, and the biggest one right now is Loom doesn't exist in a way that we can actually run it now. That's where the things are.
Yeah. Okay. We can always invite Ron to come and talk to you guys.
Yeah.
Okay. Well, so look, I have 2 more questions on the list, but one of them is a very long question because it's a lot of details. This is about CI/CD, about performance optimization, benchmarks, and I think given we've got 10 minutes left, let's skip that one and see whether we can turn that into something more constructive for people. So
we have one just that's connected to the one we just had. Again from Bitai. So I wonder who will port the hundreds of JDBC drivers to reactive stack compared to Loom architecture. The existing JDBC drivers already work with fibers. So first of all, there isn't 100 JDBC drivers. Is there more than 5? That's, I think, MySQL, Postgres, DB2, Oracle,
MS SQL.
I'm probably missing some.
MariaDB.
Yeah. So there is a limited set, and yes, but as right now we have not all of them. We have the important ones. But this I'll just say that those who reported today in Vert.X, I actually don't know who actually did the in Vert.X, but there are people who wrote most of them in the Vert.X stack. I know the Oracle guys have done one in I forgot the framework now they did for, but
ADBA or whatever.
Yeah, R2D.
Yeah, well, also internally, Oracle's driver internally, if I remember correctly, it actually has a reactive core inside of it for the way they process I/O. So while the interface is blocking, under the hood, they're actually using.
That's a great point that I wanted to bring up myself. That it's so much easier to have a reactive core and then expose a blocking facade to use than do it the other way around. I mean, it just.
Right. And that's the thing is that what I was kind of pointing to is the people will move there if there is an advantage to it, and we've shown and seen there are, but we are in this funny situation right now. It's like beta versus VS8 battle of which reactive API thing gonna win, and that's just like I'm old, so I can say how it was before JWC. Like before JWC was it's like 20, 50. Well, how old am I? 16, 17 years ago. There was like OC from Oracle, Microsoft had something else, and and it was horrible. But everyone was like kind of doing 2 or 3 things at the same, and then suddenly people got a click, and okay, JWC, which was a choice that cut something out but made something uniform. And I think you'll see the same thing in reactive database access. So yeah, okay. Let's go.
Right. So what I'm going to suggest we do is there's a question from Dorian. I said this long one about CI/CD processes.
Take that normally. Yeah.
We'll deal with that separately. So unless you have any more things on the chat that you want to talk about, I have a very important question. Okay, so the question is from Antonio, who says, I've read here and there about Quarkus.io version 2.0, but nothing official. Fake news, or do you have a roadmap in mind?
So, you have a short, but I'll say yes. We've talked about Quarkus 2, and I'm going to put quotes up here because we don't want to actually make this a hey, we changed the whole world kind of thing. There's a main driver, and we put it on a GitHub epic last week because we realized, hey, we start calling this Quarkus 2, we should make it concrete. So the Quarkus 2 effort is we want to migrate to Vert.X 4, and Vert.X 4 has done a few changes in the APIs. So the Quarkus 2 is literally, hey, it might make sense to kind of say, hey, there is a point where there will be a breakage for some people. We want to keep it as minimal as possible, but we don't know exactly how big that is yet. So that's why we call it Quarkus 2. It's probably going to be called Quarkus 2 just to kind of signal it. But what I'm trying to get to is like one of the reasons why we're doing releases very often is besides being good at handling, getting new things in and fixes, etc., is also to be able to evolve things without breaking people too much. But we do know that when we get to Vert.X 4, there'll be more. It sounds horrible, but it's not. Like there'll be more breakage than we've seen before. But we had a plan of trying to roll that out. Starting about now with Vert.X 4, but it's taking a bit longer. So there is an issue. If you look for Quarkus 2 in GitHub issue, you will find it. And it outlined the issues we have. And the main thing there is just how do we get to Vert.X 4 without breaking too much things? And I think that's kind of boils down to what Quarkus 2 is at the moment. I'm not sure, Jason, is there anything I'm missing?
Which the one thing I just want to add is that, what Max is talking about is primarily for the perspective of extension authors. So like if you're writing extensions, and that's the biggest reason why we would say 2.0 is because it makes it easier for extension authors if they can target the right, version that's available and understand that there's a significant change that can occur. But if you're actually using some of the other APIs, like you're using the predominant ones, like say JAX-RS, using REST Easy, or using Spring APIs, you probably won't see much of a difference because it's a under the hood kind of change. So I just want to mention that just in case anybody's like, oh my God, I'm going to have to hold off moving to 2. That not that it's. I don't want to. I don't want to underdo it and say, oh no, it's fine. Nothing will be different. But generally, we try to kind of signal in our versions if something's really going to be a big deal, and Vert.X moving to Vert.X 4 is a big change for those that are using those APIs.
Mm-hmm.
Yeah,
but yeah, like Jason said, most people aren't, right? Most people won't interact with most people using Quarkus don't interact with Vert.X directly. At least that's from what we see from all the community feedback and issues and stuff like that. So yeah, like Jason said, I would assume that most people won't have a single issue with this move to Vert.X 4.
Yeah. Okay. So there was there's just one question from David, kind of left field here. He's saying we are running our apps in GKE. I guess that's Google Kubernetes engine.
Kubernetes engine, yeah.
Yeah. Are we missing anything by not using OpenShift?
Yes, a lot.
Oh yeah, you take it.
No, you go ahead.
Actually, it's been a while since I used Kubernetes, but what are you missing out? Well, OpenShift has more, like, it has this operator model. It has the more developer console, the admin console, things that GKE has their own version of. But if you're talking about from an OpenShift, from a like Quarkus perspective, do you miss something out there? I'm actually not sure. We support secrets. We can read the config maps. Is there? One thing we're working on is this thing called the service binding spec and the service binding operator. But you could also again run that in GKE if you want to. From a Quark. So this. So if you're asking from a Quark perspective, we are trying to make the change in delta there as minimal as possible, basically. But in OpenShift, there will just be others there. No. I'm not trying to compare OpenShift and GKE, those two products, but from a Quarkus, yeah, it should be more or less the same, because we're trying to program against the normal Kubernetes APIs. The stuff that you're missing is, well, and again, because you don't have it in GKE, so you don't miss it. In OpenShift, there's this thing called S2I deployments and a specific way of deploying, and we have support for that in Quarkus. But there's nothing like that in GKE, so you don't miss it. Kind of thing.
If I may say so, as someone who started Kubernetes like before they started working here at Red Hat, for me, OpenShift, the best things I saw like OpenShift had versus like vanilla Kubernetes which didn't have, was like the console is so much better. Like it's way better. There's so much stuff you can do versus the regular Kubernetes console. Then second, the routes are so much better than Ingress. Ingress is such a pain to work with, while OpenShift routes just work out of the box. The fact that OpenShift has a dedicated registry is huge, because it's a pain to have to either have your registry outside of Kubernetes or like find a way to deploy it inside of Kubernetes. That is huge again. And there's a lot of like little stuff that makes your day-to-day a lot easier. So if you're like a Kubernetes expert, then you can get all this stuff done, right? But if you're like someone who just wants to play with it, it's such a pain to get vanilla Kubernetes just to set up your proper workflow as a developer.
Yeah. Oh yeah, I forgot. The whole embedded registry is a big deal.
Yeah. For me, that was huge.
I'm so used to it. So. But yeah,
you know, big picture thing to add in there is that one of the things that's nice about OpenShift is that it is abstracted from the cloud providers. So like, you know, just if you're thinking like long term, you know, like, you know, where is your service going to run? Is it going to run on Amazon? Is it going to run on Google? Is it going to, you know, run on a Microsoft? You want to have that flexibility to be able to move. And so one of the nice things about OpenShift is you can run it yourself. You can run it on any of the providers. So if they change their pricing models or whatever, you're not like, you don't find yourself in trouble, you know, later on trying to suddenly re-architect your application at the last minute.
Yeah, and that's I definitely agree. And that's comparing OpenShift versus any other Kubernetes distribution, then you have those advantages. But from a developer Quarkus perspective. Yeah, I think there's nothing you'll lose, but yes, you will have it easier in OpenShift because of the routes and the registry and all the other stuff around. But those are, well, we're trying to make them external for Quarkus. And we actually trying to, in our different extensions, we have a Kubernetes extension and we have an OpenShift extension. We have a Minikube extension, where we try and capture one of those like gotchas, so you still have a decent experience. But yeah, definitely right now, if you're having OpenShift, you have much less to do than on the others. But we try to do what we can in Quarkus, but yeah, we can't fix the Kubernetes registry.
And Quarkus never will be tied to OpenShift, right? That's one thing we want to enable the broad community
Yes.
So it may seem like hey, there's a lot of Red Hat folks that contribute to Quarkus. Does that mean it's going to be too tied to Red Hat? That's not our
point. Sorry, let's make that clear. So I'll actually flip this around. So we actually have a mechanism in Quarkus that lets you make Google Cloud and Amazon or whatever work as smooth as they can that we have in OpenShift. There's just someone needs to go and add that extension. But right now we've added it once we can and makes sense. Either us or others can contribute it. But like if the community's distribution doesn't do X, then OpenShift can't do it. Quarkus can't do it much about it. But there is a layer in Quarkus that allows us to hide a lot of those things. So it's definitely possible. Okay, I think we're running out of time.
Yeah.
Oh, there we go.
So that was the end of the questions. Well, apart from this big one, which we'll have to talk about how we deal with it.
Yeah,
that was good. I enjoyed that. Thank you.
That was good.
That was wonderful.
And for anyone who listened in, and I'll put the tweet out again. But put a question on Quark Insights. We collect them, and then we see once we have. Apparently, we can handle about 7 in an hour. So that's what we'll go for. But let's do that. Thank you.
Yeah, it's great questions, guys. Thanks for asking.
Amazing. All right. So until next week, I guess.
Will do.
Yep.
See you, everybody.
Bye.